Math and Beats. We're going to follow up the limit laws video with a example. I think it's pretty interesting, where we can't really use limit laws, but something interesting happens. Let's take a look here. So what we're going to see right here is two different graphs. Graph of f of x on the left, the graph of g of x on the right. And what we want to do is investigate the limit as x goes to 2 of the sum of the two functions f of x plus g of x. Now, one thing that I like to show this example here is that we have the limit laws for sum, right? Limit as x goes to a of the sum of two functions, f of x plus g of x, in general, right? Well, that's going to be the limit as x goes to a of f of x plus the limit as x goes to a of g of x. But remember, that's only true, right? This is true if limit as x goes to a of f of x and limit as x goes to a of g of x both exist. So it's kind of like a counterexample here, because we're investigating in our situation the limit as x goes to 2 of the sum of f of x plus g of x. But we notice that for f of x, limit x goes to 2 of f of x, it does not exist, right? Why? Well, since limit x goes to 2 from the left of f of x is not equal to the limit as x goes to 2 from the right of f of x. And something similar can be said over here on the right with g of x. Let me just get rid of some of that stuff we already wrote here. Notice that limit as x goes to 2 of g of x also does not exist. And again, that is because the limit as x goes to 2 from the left of g of x is not equal to the limit as x goes to 2 from the right of g of x. So each of these individual limits do not exist as x approaches 2. And hence, we cannot use limit laws here. We cannot say that the limit as x goes to 2 of f of x plus g of x is the sum of the individual limits, because each of them don't exist. It does not mean, however, that this limit that we're looking at has to not exist. So what we're going to do is just investigate the left-hand and right-hand limits of the sum of the two functions. So let's consider here, limit as x goes to 2 from the left of f of x plus g of x. Right? Because we could actually add the two functions up if we had the formulas, which we could do. We could come up with the piecewise formulas here. But let's just investigate graphically. What's happening here is x goes to 2 from the left. Well, notice that f is getting closer and closer to 2 as we approach 2 from the left, whereas g is getting closer and closer to 1 as we approach 2 from the left. So if we added these two functions together, they would be getting closer and closer to 2 plus 1, which is 3. So we can see here that the left-hand limit exists for the sum of the two functions. What about the right-hand limit? Limit as x goes to 2 from the right of f of x plus g of x. Well, notice that for f, as we approach 2 from the right, it's getting closer and closer to 1. And g, as we approach 2 from the right, getting closer and closer to 2. So in fact, this getting closer and closer to 1 plus 2, which is 3. And what we see here is that the left-hand and right-hand limits both match up. And hence, they're the same thing, and it follows that limit as x goes to 2 of f of x plus g of x here is actually 3. It exists. Even though the individual limits did not exist in the first place, and we could not apply our limit laws, we can still take the left and right hand limits of the actual function, f of x plus g of x here, which is just some other function, and if those left and right hand limits match up, limit still exists. In fact, if you investigate a little further here, you can notice that if we actually add up the functions, f of x plus g of x in general, notice that it's going to be defined for all the values of x, at least that we see in the graph, and when we add them up, this is just a constant function. It's equal to 3, always. And it's also equal to 3 at 2, and hence seems reasonable that this would actually work out. So that's it for the example. It's just a short example to understand, first of all, if you don't have the individual limits exist in the first place, you can't use the limit laws, okay? But even if individual limits don't exist and we combine the functions in a certain way, it is possible that the limit could exist of whatever the math operation is associated with the combination of the functions. And it just all has to do, going back to the requirements of what we need for a limit to exist. Left-hand limit, right-hand limit should match up. And if that's true, limit exists. So just keep that in mind as you go through your limits. Only apply limit laws when applicable. Okay? So that's it for this video. Next video, we're going to do a quick video on limits involving polynomial and rational functions. So that's it. Till the next video. Bye now.